6.3. When do you all submit it? Okay, I'll go and check again. Meanwhile, take out a piece of paper and look through these questions, okay? Find the acute angle theta in degrees of the following. Question 2b, we have sine theta equals to sine 81.5 degrees divided by sine 22.3 degrees. Okay, we can evaluate what is on our right hand side with our calculator. And we get 2.6064. Okay, so what is the problem with this portion? Sine angle equals to 2.6064. This value over here is greater than 1. Now, whenever we apply sine to an angle, the maximum value we can go is 1. So if your answer is more than 1, that means it is not possible to solve for theta. So you can try sine inverse 2.6064. You'll find that theta is not defined. Okay, so we conclude that no solution. It is not that there is an error in the question. It is designed this way. There is no solution to this. Okay? Next, I want to talk about question 5b. Find the unknown marked sides and the angle in the following diagram. So we have this diagram over here. This is a right angle triangle. A, D, B. Okay. So with this, we have a choice. We can start finding theta or we can start finding x. So in this case, theta is much easier to find because we just need to focus on this triangle over here. Okay, so solving for theta, I need a trigonometric equation linking 6, 8 and theta. So what should I choose? Tangent. Okay, how do we write tangent? Do we write it this way? T-A-N. Or do we write it this way? Tangent. Which one? Top or bottom? Bottom. Small t, okay? Not big T. So don't want this. Hey, we are using tangent theta equals to opposite over adjacent. Can I write it this way? O over A. Can? Can. So later on, if I substitute in values, then suppose I'm trying to find opposite. Let's say my opposite is my unknown. Okay? And I want to make opposite the subject. What will it look like? O equals to A tangent theta, right? If I want to make O the subject. Now what does this look like to you? Does this look like O equals to A tangent theta, or does it look like something else? Come on, it looks like 0, right? It looks like 0 equals to A tangent theta. So is it a good idea to use O to represent opposite? It is not a good idea. Either you write opposite over adjacent, or you can just write OPP, at least that makes more sense, ADJ. Either these two, or you straight away substitute in the value. So opposite we have 6, adjacent we have 8. Okay? So from here, theta will be equals to tangent inverse 3 over 4. And our value will be 36.869 degrees. 3 dp first. Then we round it off to 36.9 degrees. Okay? This is for theta. Now we still need to find x, the value of x. Now I want you to concentrate on this triangle over here, the big one, which is another right angle triangle. Okay, this big triangle, it has a side 8 centimeters, another side x plus 6 centimeters, and one combined angle. What is this combined angle? 23 plus 36.9 or 23 plus 36.869? 869, because we want to use the more exact value over here. Okay, so angle BAD equals to 23 plus 36.869 degrees. The value over here will be 59.869 degrees. So I'm going to highlight this portion. Do not use 36.9 degrees because it will cost you accuracy marks. Some of you have used your rounded off values and your final answer, it appears to be just a little bit off. That is the reason. Okay? So we have angle BAD is 59.869. Now we want to find BC, which is x. Let us try to form an equation with this purple angle, the side AD, and the side BD. What trigonometric ratio should we use? Which ratio should we use? AD and BD, as well as that angle in purple. Tangent again. Can we use that? Yes, we can. So tangent, small t, tangent 59.869 degrees. Over here, I want to draw your attention to this angle. The angle is in degrees. When you write the angle, you must have the units. I've rejected a lot of your homework because you refuse to write the degree symbol. So you're going to fill in all the blanks, all the missing degrees, and you're going to return it back to me. Okay? So, tangent 59.869 is equals to opposite. How much is the opposite? BD, right? Which is 6 plus x. Over adjacent, which is AD, so that will be 8. So let us try to make x the subject. We have 6 plus x is equal to 8 tangent 59.869 degrees. And therefore, x must be equal to 8 tangent 59.869 degrees minus 6. Find out what's the answer and round it off to 3SF. Because now we are searching for the length. Okay? So do the calculations yourself. Next question that I'm going through is number 7. Don't worry if you cannot copy in time. Use this time to understand what is happening. You have all the time at home. Go and look through the video again and copy it down. Okay, 7. ABCD is a trapezium where AB is parallel to CD. Okay, so trapezium. And it is a right angled trapezium. A, B, C, D. So 3 units, 6 units, 7 units. Find the size of angle theta. Now we are doing trigonometry. So where is the triangle in this question? You have to draw yourself. So let us drop a dotted line down. This is also 90 degrees. Okay? So since this is 3 units, then this must also be 3 units. And we have a side, which is a long side called the hypotenuse. It is 7 units. I have another side of the triangle, 3 units. What is this side called? What is this side called relative to this angle? Adjacent, yes. So this is our adjacent. This is our hypotenuse. So what trigonometric ratio should we be using? Cosine theta equals to adjacent which is 3 over 7. So theta equals to cosine inverse 3 over 7. Get your answer of 64.623, round it off to 64.6 degrees. Okay? Then in part B, we want the length of BC over here. The length of BC. Since these are all 90 degrees, the length of BC will be the same as the length of D drop down to this point. For convenience, let us call this point E. Okay? Let us call it point E for convenience. So, the length of BC is equal to the length of DE. BC equals to DE. We are going to use the same right angle triangle. Now, I want to form an equation linking the side DE with any of my other sides or with the angle. What do you prefer? Do you want a trigonometric ratio or do you use Pythagoras? So if you want to use ratio, you want to use trigo, you can use sine, cosine, you can use sine, you can use tangent. Which one you want to use? And why do you want to use this as compared to Pythagoras? So you must think why you want to use one of those as compared to Pythagoras? Yes, you already have the angle, it is convenient to use it. But what is the problem? What if your angle, you calculated it wrongly? Then part B will be wrong also, right? So if you choose to use trigo, if you choose to use Pythagoras theorem, you have a higher chance of getting a right answer, as long as you don't make careless mistakes. So that is what I'm going to try to do. DE square plus AE square equals to AD square. So DE square equals to AD square minus AE square. And AD will be equal to 7 square minus AE, which is 3 square. So DE equals to square root of 49 minus 9 equals to square root 40. Okay? This, we find out what is the value. Square root 40 gives us 6.3245 units, which is in cm, and we can round it off to 6.32 cm. Now if you use your trigo, you should arrive at the same answer. It may not be as exact as me because in the previous part, your theta, this value over here, is also not exact. It is already truncated because there were more values, there were more digits at the back which you ignored. Okay, they are quite small. So if you had used this, your answer may be slightly different, but if you round it off, you should get the same answer. Okay? And finally, to find the area of the triangle, of the trapezium, area of ABCD. What is the formula for the area of a trapezium? What is the area for a trapezium? Half times sum of parallel sides times perpendicular height. Okay? You can choose to do it this way, or you can choose to break it down into this rectangle. In this case, it is called a square, plus the area of a triangle. Or you can simply apply this. So that will give us half times 3 plus 6, over here, sum of parallel sides, times the height, perpendicular height. How much is it? Do we want to use 6.32 or do we want to use 6.3245? Yes, because it is more accurate. 6.3245. Get the answer, round it off. Don't forget your units. Okay? Okay, so that's all for 6.3. I'll go on to the common errors you have for 6.4. Am I going very fast? But can you all follow? Cannot follow. Mars can follow? Okay, some of you can follow, some cannot follow. Huh? But because we are a little short of time, I expect you to go back and view the video. Okay? So now, 6.4. 6.4, I want to go through question 11. Ali stands 2.5 meters away from a tree. Where he looks at the top, the line of sight makes an angle 40 degrees with the horizontal. His eye level is 1.6 meters from the ground. Find the height of the tree. Okay, so this is his eye. He is looking up at a tree, at the top of the tree. Over here we have 40 degrees. Trying to find this. And this is 1.6 meters. Okay, to find the height of the tree, we can divide the height into two parts. The lower portion, which is over here 1.6 meters, and the top portion, which we don't know. But once we manage to find the top portion, we can add it to 1.6 and we get the height of the tree, right? Okay, so let us isolate this triangle that I'm going to highlight. And this triangle looks like this. (40 degrees). This is a question mark over here. What else do we have? Oh, there is 2.5 meters here. So this is 2.5 meters. Okay, now we have a right angle triangle. I need to know this side. What is this side called relative to the angle? Opposite. And what is this side? Jason, what trigo ratio should we use? Yang Kun? What trigo ratio should we use? Huh? I can't hear you. Louder, louder. Huh? This diagram, you are not listening. Tangent, thank you. Tangent, 40 degrees equals to opposite. Right now, I do not know what opposite is. I shouldn't just write O because it looks like 0. So we're just going to write OPP over adjacent, which is 2.5. So opposite is equals to 2.5 tangent 40 degrees. Get the value. Yep, 2.0977 meters. I do not want to round it off because this is an intermediate step. So height of the tree is 1.6 plus 2.0977 equals to 3.6977, round it off, 3.70 meters. Right? Any questions on this? Winnie, do you get this correct? Okay, good. Next is question number 13. We have a vertical building and there are two cars at A and at B. Of course, the building is vertical. Okay, this is point F, point T, and 92 meters. Find the height of the building. Okay, IQ question. How many triangles do you see in this question? Three triangles. Now we want to find the height of the building using trigonometry. So I want to use a right angle triangle. How many right angle triangles do you see? Two. You see two right angle triangles. But we just need to use one of them to get us the height of the building. So which one should we use? Sorry? T, B, F. TBF to find the height of the building. Okay, let's try that. If I'm using TBF, then this is 50 degrees. How do I find the height of the building? How? This one cannot, because you don't have enough information. So let us try the other triangle, which is TAF. TAF, angle 33 degrees, 92 meters. Okay, so which trigo ratio should I use? Sine, not so, sine. Sine 33 degrees equals to opposite. You can just write OPB or write TF, since we already have the points defined for us. Over hypotenuse, which is 92. So TF equals to 92 sine 33 degrees. We get 50.106 meters. Round it off. 50.1 meters. Okay? That is part A. Now part B, we want to find the distance BT. Okay, over here. BT. We have the height from previously, which is 50.106. I am going to write down the value 50.106 here in my diagram, so it is easy for me to refer, and I do not want to put in a round off value, because that's not very accurate. So now I will look at my other right angle triangle. Okay, so F, T, and B, this is 50 degrees, and this is 50.106 meters. To find the length of BT, I need another trigo ratio. So part B, what ratio, which function should I use? If I want the hypotenuse, I'm given the opposite cosine. Sine? Cosine? Sine. We should be using sine. Sine 50 degrees equals to opposite. Now it is 50.106 over BT. I'll just highlight this. 50.106 from here. So BT is equals to 50.106 over sine 50 degrees. Okay, divided by sine 50, you get 65.409. Round it off to 65.4 meters. Okay, so far still quite basic. I'm going to include this value, 65.409 meters here. Okay, now I need to find the length of AB for part C. Okay, what's the plan? What's the plan to find length of AB? Irfan, can you give me a suggestion how I can find the length of AB? The rest thing also. Irfan, are you thinking? You thinking or you digging for your answer? Shh, the rest, lower down the volume. Yes, Irfan? Find AF, okay? Then what do you do after that? Okay, his method, his approach is to find AF, then subtract BF. Yeah, that sounds logical. So question is how to find AF. So part C, he wants to use AF minus BF. Okay, so how to find AF? Okay, yes, it is a good idea to use cosine because we are going to be finding AF and we are using information given 33 degrees and 92 degrees. In this case, we are not subject to any errors that we might have made earlier on. So, cosine 33 degrees equals to AF over hypotenuse, which is 92. So AF equals to 92 cosine 33 degrees. Okay, right now, please look up at the screen. Look up at the screen, everybody. Wei Hao, Ali, Irfan, look at the screen. Right now, I do not want to evaluate this yet. I'm going to leave it like this. Then I'm going to find the next one, which is BF. Okay? So again, cosine 50 degrees equals to BF over the hypotenuse, which is BT you found earlier on. BT was 65.409. Okay? So BF is equals to 65.409 cosine 50 degrees. Now I have an exact value for AF. I have quite an exact value for BF. And I can use our equation that Irfan suggested with these values and subtract and find the answer yourself. Okay? Any questions? Okay, then one last question for your homework. Question 15. I think I only had 2 students who got this fully correct. Okay, let's see. Now I have a plot of land. It is in the shape of a trapezium again. Okay, this is all the information that was given. Find the perimeter of the land. Find the perimeter of the land. We already know one side, BC. We know AB. So obviously we need the lengths of the other 2 sides. So in my diagram, I'm going to introduce a new point. Over here, let us call this point E. And I have just created a right angle triangle. So what is the distance from E to A? 20.3 as well. What is the angle DCE? Over here, what is this angle? There is a 90 degree over here. Okay, so we get 25.6 degrees. This is 25.6 degrees. Once this is done, is it much easier to find the length of DE? Yes, right? Because horizontally, this will be 31.8. And I need to find the opposite side. I have the adjacent, and I have I need to find the opposite. Oh, okay. Yeah, I'll record on. Thanks. So I have the adjacent side. I need to find opposite side. I have an angle. I should be using tangent. Tangent 25.6 degrees equals to opposite, which is DE, over adjacent, 31.8. So DE equals to 31.8. Tangent, 25.6 degrees. We have 15.236. Okay? This is an intermediate step. I will leave it like this. I'm not going to round it off. Next thing I should find is the length of DC. So I have an angle. I have the adjacent. I need to find hypotenuse, which is the trigo ratio we should use. Xiao Wei, what trigo ratio should we use? When I have adjacent, I need to find hypotenuse. Cosine. Cosine 25.6 degrees equals to adjacent, which is 31.8 over DC. So DC is equals to 31.8 over cosine 25.6 degrees. Work this out to get 35.261. 35, round it off to 35.3. Oh no, I don't want to round it off yet. Sorry. Okay, so now I have DC, which is 35.261 meters, and DE I found it to be 15.236. So now the perimeter is straightforward. We just add everything up. Okay, that's for part A. Add all lengths together. Okay, so part B, to find the area of this trapezium, again we use half sum of parallel sides, which is AD plus BC times AB. Substitute in everything yourself, round it off, you'll get the correct answer. Okay?